Here's a really big and interesting version of a problem related to combinations and probability. We'll go back to the Jay Leno example. In this case, he wants to take 6 cars, and he's got 100, or well, he wants to take 6 vehicles, and he's got 169 cars and 117 bikes to choose from. But he's not sure. Let's see. Okay, he's not sure how many cars and motorcycles. If you had to bet, what's the probability he decides to take at least 4 cars? At least 4 cars. So at least 4. That's going to be a new type of problem for us to deal with. Let's see what is required if we want to figure out how to calculate the probability of choosing at least 4 cars. We have some experience here. We know that in down here we're going to choose. Let's say he does choose 4 cars. So let's say we know for sure he's choosing 6 vehicles. So we've got a total of how many again? A total of 286 vehicles. So in the denominator, we'll go ahead and say that we're going to choose from the 286, we'll choose 6 vehicles. That's the easy part. Then we have to say to ourselves, okay, how many ways could he choose 4 cars? Let's just focus on that for right now. So how many ways could he choose 4 cars? Well, he's got 169. And we want to know how many ways he could choose 4. Now, you might think that our job is done here. Or at least for that part of it. You would think, hey, 4 cars. The only problem is he wants to take 6 vehicles. So when we look at the probability of how many ways that he'll take 4 cars, it's assumed that he's also going to take 2 motorcycles. So even though it's not said so in the question here, we have to go and tack on. We have to multiply times the number of ways that he could take the 2 extra motorcycles that would be required to make 6 vehicles. So again, we'll do 117, comma 2. Now, because it says at least 4, we're going to have to do some more stuff. And we're going to go ahead and add that on as an or. Because when we say at least 4, what we really mean is this. We mean that we want to know the probability of 4 cars and 2 motorcycles, or the probability of 5 cars and 1 motorcycle, or the probability of 6 cars. And then we don't have to worry about motorcycles because that'll take up all 6 vehicles. So we're going to have to do all that math. Remember, when we see or, we're going to have to do pluses. So let's go ahead and let's add the next fraction on. The good news is the next fraction has the same denominator. We're still, we want to know the probability of choosing 4 cars and 2 motorcycles here in this first fraction. So, but we're still choosing 6 vehicles from 286. So the same is true here. We're choosing from the 286 vehicles, we're choosing 6. That's the total number of outcomes regardless of what we get, cars and motorcycles. Now what we're interested to know is how many different ways could we choose. Now we're on up to 5 cars and 1 motorcycle, and because at least 4. So how many different ways could we choose 5 cars from 169? And we're going to need 1 motorcycle. So how many different ways could we choose that 1 motorcycle from 117? So we do all that math. So there's a lot of stuff going on here. And that's not all. We still got to add a little bit more. And for this next part here, we end up with, again, the same denominator. Now we're looking at the probability of choosing just 6 cars. But again, we want to look at the number of ways that we could choose 6 vehicles. first. That's the total number of possible outcomes of choosing 6 vehicles from 286 that are possible. And then let's look at specifically how many different ways could we choose just 6 cars, and there's only 169 cars, so we can only do that C169 comma 6. And when we add up all those probabilities, it'll be kind of interesting. You do get a fraction. With all of this, you get a number that's less than 1, between 0 and 1. But basically that's the gist of it. This is a big, interesting problem. We take combinations which let us count how many ways. We take we put them in a fraction to make them into probability. We take ands, which require we take let's see here, four cars and 2 motorcycles, and so we do multiplication. 5 cars and 1 motorcycle, so we do multiplication. And then we have all the ors, and with these ors we do addition. So there's a lot of stuff going on in here. You're going to have some practice problems to try. Make sure that you take good notes. You're going to need these notes.